Have you noticed your Subaru's check engine light just came on, or your CVT feels sluggish, and the dealer wants hundreds of dollars just to diagnose the problem? What if I told you there's a simple reset procedure that can fix most electronic Subaru issues for free? Not just clearing codes temporarily, but a legitimate master reset that makes the car relearn its systems and solves hidden glitches. Today, I'll reveal the exact reset sequence mechanics rarely share, because it eliminates expensive diagnostic fees and unnecessary parts replacements. Stick around. This could save you thousands and improve your Subaru's reliability. Let's dive in. Why this reset works when nothing else does. Modern Subarus are essentially computers on wheels, with more than 40 control modules managing everything from engine timing to seat heaters. These modules continuously communicate, adapting to your driving style, environmental conditions, and component wear. Sometimes, however, this learning becomes corrupted. A weak battery, a misbehaving sensor, or even a software glitch can cause a computer to make decisions based on bad information, leading to symptoms like rough shifting, shuddering CVDs, erratic throttle response, or dashboard lights that seem to appear out of nowhere. Mechanics often charge hundreds of dollars to diagnose these ghost problems, but the master reset clears the corrupted data, forcing all modules to start fresh and revealing what is truly wrong, if anything at all. This is why it works when traditional diagnostics fail. Step 1. Battery disconnect and capacitor drain. To begin the reset, turn off the engine and remove the key. Open the hood and disconnect the negative battery terminal. Then wait for 2 minutes. Pressing the brake pedal 5 times during this interval drains all capacitors, ensuring the electrical system is fully cleared. Waiting an additional 15 minutes before reconnecting guarantees the computer memory is reset and all voltage stored in the system is dissipated. This simple step addresses corrupted learning from minor voltage spikes or sensor errors, giving the Subaru a fresh start and eliminating many false alerts that could otherwise lead to unnecessary repairs. Step 2. Reconnect and wake systems. After reconnecting the battery securely, open the driver's door, insert the key, and turn it to the on position without starting the engine. Wait 30 seconds, then turn it off. Remove the key and close the door. This gradually wakes all the vehicle's modules, allowing them to establish baseline readings in a controlled manner. Performing this step slowly prevents sudden voltage fluctuations and prepares the systems for proper relearning. It ensures that all sensors, from engine to seat heaters, begin communicating accurately, which is critical for preventing ghost warning lights. Step 3. Steering angle sensor calibration. With the engine running, fully turn the steering wheel to the left, hold for 2 seconds, then fully right, holding for another 2 seconds. Center the wheel precisely and drive straight for about 100 feet at a low speed. This procedure calibrates the steering angle sensor, fixing common VDC, ABS, and traction control warnings caused by corrupted learning. Proper calibration ensures the vehicle interprets wheel position correctly, preventing false alerts while braking or cornering. Many Subaru owners notice immediate improvements in stability and handling after completing this step. Step 4. Throttle position relearn. Next, while the engine is running, press the accelerator fully to the floor and hold for 10 seconds, then release and allow it to return to idle. Turn off the engine and wait 10 seconds. This process teaches the ECU the correct throttle positions, eliminating high or erratic idle, restoring smooth acceleration and resolving hesitation. Drivers often notice fuel economy improving after performing this relearn, as the computer can now optimize air-fuel ratios based on correct baseline readings. Step 5. Transmission relearn cycle. Once the engine reaches normal operating temperature, shift into drive and accelerate smoothly from 0 to 40 miles per hour, maintaining that speed for about a mile, then decelerate to a full stop. Shift to park. Turn off the engine, wait 30 seconds, and repeat the sequence 3 times. This allows the CVT and automatic transmission to relearn proper shift points and torque behavior. Many symptoms, including shuddering, rough shifts, or gear hunting, often disappear after completing this step. Performing multiple drive cycles ensures the transmission adapts accurately to current vehicle load and driving conditions. Step 6. Final system stabilization. Start the engine and let it idle for 5 minutes without any accessories, such as AC or radio. Then take the car for a 20 to 30-minute drive, mixing city and highway conditions with left and right turns, acceleration, and braking. This final step allows all vehicle systems, engine, transmission, brakes, and steering, to communicate and relearn together. By the end of this process, most warning lights, throttle issues, and electronic glitches should be resolved. Subaru owners often report a dramatic improvement in performance and the disappearance of phantom alerts. What this reset can fix. This master reset addresses the vast majority of electronic issues in modern Subarus, including check engine lights triggered by false fuel trim codes, misfire codes that aren't real, CVT sluggishness, and false traction control or VDC alerts. Erratic throttle response, high idle, and minor electrical glitches like power windows losing auto-up functionality are also corrected. If these issues persist after the reset, it likely indicates a true mechanical failure that requires professional attention. This makes a reset not just a diagnostic tool, but preventive measure, allowing owners to differentiate between actual component failures and corrupted software learning. Preventing computer learning issues. To keep your Subaru systems healthy, maintain a strong battery, as weak or old batteries can corrupt module memory. Always use OEM or high-quality aftermarket sensors to prevent erroneous data from causing false warnings. Intermittent sensor problems should be addressed immediately, as even occasional failures can disrupt learning. Follow proper battery disconnect procedures when working on electrical systems to avoid accidental memory loss. Installing VIN-specific software updates ensures modules continue learning correctly and prevents recurring issues. Finally, perform a master reset after replacing major components, so the computer relearns baseline behavior rather than compensating for old faulty parts. Monthly maintenance reset. Subaru owners can prevent small learning drifts from becoming major problems by performing a simplified monthly reset. Disconnect the battery for 5 minutes, reconnect, and start the engine, letting it idle for 2 minutes. Then drive for 15 to 20 minutes at mixed speeds. This works like rebooting a computer, keeping all modules synchronized and preventing minor glitches from snowballing into larger electronic or performance issues. High-mileage vehicles particularly benefit, as repeated small corruptions over time can cause multiple warning lights or abnormal CV behavior. Regular monthly resets maintain smoother performance and peace of mind for long-term owners. Advanced reset techniques. For persistent or stubborn issues, an extended battery disconnect overnight ensures a deeper capacitor drain. Performing multiple transmission relearn cycles, 5 to 6 instead of 3, provide the ECU more data for accurate adaptation. Resetting the system across temperature variations, from cold start to fully warmed engine, teaches the computer to operate optimally in all conditions. Introducing varied loads during the relearn drive, including hills, acceleration, and highway speeds, ensures modules can adjust to real-world driving. While these advanced techniques take more time, they often resolve the most stubborn electronic issues that standard resets cannot fully address. Why mechanics don't tell you. The automotive repair industry profits heavily from diagnostics and unnecessary part replacements. Shops charge $150 to $600 for system checks, and technicians earn commissions on new components. A master reset eliminates these revenue opportunities because it fixes the problem for free. While most mechanics are honest, the business model rewards performing repairs, not preventing them. By knowing the reset, owners can avoid costly diagnostics and repairs, saving hundreds or thousands while maintaining vehicle reliability. This knowledge gives Subaru owners control over minor electronic issues without opening their wallets unnecessarily. Limitations of the reset. It's important to understand what this reset cannot fix. Sensors that fail completely, such as a dead oxygen sensor or MAF sensor, need replacement. Mechanical wear in the transmission, including worn clutches or damaged belts, requires actual repairs. Vacuum leaks or air intake problems, faulty ignition components, clogged fuel injectors, or internal engine damage cannot be solved with a reset. The procedure addresses software and learning issues, not physical hardware failures. Performing the reset clarifies which issues are real, helping owners make informed decisions and avoid replacing parts unnecessarily. This master reset is a powerful, free method to fix most electronic Subaru problems. It clears corrupted learning, restores smooth throttle and transmission response, and eliminates phantom warning lights. Performing it regularly can prevent minor issues from becoming major repairs, saving time and money while preserving the longevity of your vehicle. Even if problems persist, the reset helps identify genuine mechanical issues that require attention. If you found this guide helpful, share and subscribe for more Subaru tips, maintenance secrets, and insider tricks. Taking control of your Subaru's electronics can save hundreds or even thousands of dollars while keeping your vehicle running reliably for years.